The unit canceling method, which you can also call dimensional analysis or the factor label method, uses things called conversion factors to convert units or rates to other units or rates. This is called a conversion factor. A conversion factor looks like a fraction, as a number and a unit over another number and another unit. The units are different and the numbers will often be different, but the important thing to remember about a conversion factor, I'll label that here, is that the values of them are the same. I'll write that again, factors. So 4 quarts is 1 gallon. They are equivalent in volume. They're just different ways to write it. Just as a reminder, the numerator is the top number. The denominator is the bottom number. Coefficients, those are the numbers in front. So if you have something like 3x, 3 is the coefficient. So the coefficient is the front number in front of the unit. In this case, the coefficients are 4 for quarts and 1 for gallons. How to use these is pretty straightforward. You always remember, the thing that I always say to remember is start with what you know. So here's one problem, and once we work through it, it'll make some more sense. Parking lot problem. I have 22 quarters, but I want nickels. How many nickels should I get? What this is really asking is, how many nickels is equivalent to 22 quarters? You have 22 quarters. You want to find the number of nickels. And you know that 5 nickels equals 1 quarter, because each nickel is 5 cents, and 5 times 5 is 25 cents, which is 1 quarter. This right here is your conversion factor. Remember that these two things are equal in value, but they're not equal in units. If you drink 4 quarts of water, or if you drink 1 gallon of water, you will drink the same volume of water. Whether you have 5 nickels or 1 quarter, you have the same number of cents. So we're gonna write our conversion factor as one of two things. You can write it as 5 nickels is 1 quarter, or you can write it as 1 quarter is 5 nickels. But which one do you use? Do you use this conversion factor or do you use this conversion factor? It depends on what you start with. We are always going to start with what we know. And what I mean by start with what you know is that you know you have 22 quarters. You do not know how many nickels that is equivalent to. So this is what you know. And the way that I do it is I always put what I know over the number 1, because anything over 1 is itself. Putting what you know over 1 helps keep your fractions or your conversion factors aligned. There's many ways this can be represented, but they're all mathematically equivalent. So I'm going to put what I know, which is 22 quarters. I'm going to put that over 1, just because that lets me know that's where I'm starting. What I know goes over 1. I'm going to put a multiplication bar, or a multiplication sign, and then a fraction bar. This is where my conversion factor is going to go. I started off with 22 quarters, which means I want to cancel quarters. I'm going to go from quarters, so I put it at the bottom. I don't want quarters, so they're going to cancel out, as you'll see in a second. I'm going to go from quarters to nickels. Whenever something, like a unit, is on the top and on the bottom, it will cancel out. How are they equal to each other? Knowing that this area is going to be my conversion factor, what am I actually going to put in there? You don't have to cancel the units out right now. You can cancel them out later, or you don't have to cancel them out explicitly. But I know that 1 quarter is equivalent to 5 nickels. My quarters canceled out, But my nickels did not cancel out with anything, and that's good because that's what I want. So I'm going to circle that unit, knowing that that's the unit that's going to carry over to be my answer. Then you look at the numbers and you deal with the numbers mathematically. 22 times 5 is 110. And then we're going to say nickels. Units are important and units are required. If you just put 110, there's no way to know that whether you mean nickels or quarters or pennies or whatever. So the big idea is start with what you know. We knew we had 22 quarters. Write your multiplication bar or a multiplication symbol and a fraction bar. And then set your units up before you do your numbers. So I did the purple parts first and then I did the blue coefficients. I set my units up so that the quarters would cancel because I don't want quarters. I want nickels. So I put nickels on top. This part right here should be equivalent to each other. There's plenty more of these we can do to get in the habit of doing it. First, ask yourself for this side street problem, after I read it, how many teaspoons are in 3.2 cups? Remember that sig figs carry through, so this is 2 sig figs. What are we given? We are given 3.2 cups. And I call this the what I know, or what you know. And you know that's going to go over 1. That's going to be what you start with, and from there you work forward. I want to find teaspoons. Number of teaspoons in 3.2 cups. Here are some conversion factors. 1 cup is 16 tablespoons. That's what TBS is, or TBSP sometimes. And then 1 tablespoon is 3 teaspoons. It seems like a lot, but I'm going to start off with what I know. I'm going to make that orange. What I know is I've got 3.2 cups. And that goes over 1. Once I put my multiplication symbol and my fraction bar for the first conversion factor, I know I need to get rid of cups, so I need to put cups down here, right? What's the easiest thing to go to from cups? According to this, I can go to tablespoons from cups pretty easily. There are 16 tablespoons in 1 cup. So I'm going to go from cups to tablespoons. And how are they equivalent to each other according to this? 1 cup is 16 tablespoons. So 1 cup is 16 tablespoons. As of this moment, cups have canceled out, and I'm in tablespoons. If I were to stop right now and did 3.2 times 16, I would find out how many tablespoons are in 3.2 cups. But the question is asking for teaspoons. So I need to go a little bit farther. Since I'm currently in tablespoons and I want to get out of tablespoons, so I'm going to put it down here so that it cancels top and bottom. I'm going to go from tablespoons to teaspoons. So setting up my units first, I'm going to put TSP for teaspoons. And according to this equivalency, or this conversion factor, 1 tablespoon is 3 teaspoons. As of right now, tablespoons have canceled out. Check to see if this top right unit is the one you're looking for. We are looking for teaspoons. This is the abbreviation for teaspoons. So, with cups canceled, top bottom, and tablespoons canceled, top bottom, I'm left with teaspoons, which is exactly the unit I want. So right now, I'm just going to do the math. And when I do the math, I will get 153.6 teaspoons. This is too many sig figs. Remind yourself that this is actually 4 significant figures. But according to my problem up here, I am only allowed to have 2. Remember that since these are exact conversions, they have infinite number of sig figs, so you don't worry about this being 1 sig fig, or that being 1 sig fig, or this being 2 sig figs. What matters is this measurement up here. 3.2 cups has 2 sig figs. So my answer, which has 4 sig figs, needs to be cut off to 2 sig figs, which means I can keep the 1, I can keep the 5. The other ones have to turn into zeros. So 150 would be how I would report it. Approximately 150 teaspoons. With my units. So the big idea, start with what you know. Cancel units. Top, bottom, until you hit the one you want, and then circle it. And then that's where you stop. Alright, this one is how many feet are in 0.41 meters? So what do I know? I know I have 0.41 meters. That's what I'm starting with. I want to find feet. And here's some things I know. So if I'm given 0.41 meters, I will start off with that. 0.41 meters over 1. Put what you know over 1 just so you know it's where you're starting. It keeps everything in order. You don't have to, but it helps to orient yourself. I need to get out of meters. I don't want meters. I need to work toward feet, but I don't have an exact conversion that gets me directly from meters to feet. So I need to put meters down here, knowing I need to get rid of it. But what can I go from meters to centimeters? If I'm going to go from meters to centimeters, I know that 1 meter contains 100 centimeters. Centi means hundredth. So there are 100 centimeters in a meter. I will cancel the units out later. I need to go from centimeters since I'm still looking for feet. I'm going to go from centimeters. Where can I go from centimeters? I can't go directly from centimeters to feet easily, but I can go from centimeters to inches because I do have a conversion factor. So centimeters to inches. 1 inch contains 2.54 centimeters. In order to determine where the 1 goes, if there is a 1 at all, it depends on the bigger unit. Since meters are bigger than centimeters, 1 meter will contain a larger number of centimeters. Since centimeters are a smaller unit, 1 inch will contain a larger number of centimeters. Now that I'm in inches, I can go easily from inches, so I'll put that on the bottom, to feet. Would I put 1 here and a 12 here? Is 1 inch equal to 12 feet? No, it's not. You always got to think logically about what you're doing. 1 foot is 12 inches. Remember that these conversion factors, which means these things on top and bottom of each other and the little fractions, they must be equivalent in magnitude, top and bottom. 100 centimeters is a meter. 1 inch is 2.54 centimeters. To see how the units cancel, you should always be able to cancel them out like this. Meters, meters, those are gone. Centimeters, centimeters, those are gone. Inches, inches, those are gone. But what is not gone is feet, because that's what I was looking for. You should not be able to cancel out the top right unit if it is what you are looking for. At this point, you have to do the math. Plug this into your calculator. The easiest way to do that is the way that I do it, and you can do it any way you want. That makes sense mathematically, is you can type in the entire numerator, so 0.41 times 100 times 1 times 1, then press enter, and then divide that by 2.54 times 12. The big idea is they could go in parentheses. So if I were to condense this into one operation, it'd be 0.41 times 100 times 1 times 1, that's the entire numerator, all over the entire denominator, in parentheses, which is 2.54 times 12. With calculating all of these different numbers in their positions, it just comes with practice. Putting this into your calculator, I would get 1.3486 feet. That's a lot of sig figs. How many sig figs am I allowed to have according to this? This is 2 sig figs. If I want and only can have 2 sig figs, I have way too many. I can keep the 1, I can keep the 3, and I've got to cut the rest off because they're not significant. So that turns into about 1.3 feet. That's what we did as our conversion. So the metric system units, the base unit for, and this is just a review, the base unit for length is the meter. The base unit for volume is the liter, and the base unit for mass is the gram. In physics and sometimes chemistry, kilograms are used because grams are so small. It just depends on what the situation is. The abbreviation for meter is M, the abbreviation for liter is L, and the abbreviation for gram is G. Some common chemistry units that derive from meter would be a centimeter or a millimeter, a micrometer. This symbol here is a mu. It looks like that, like a U with the tail in the front. It means millionth. So a centimeter is a hundredth of a meter, a millimeter is a thousandth of a meter, a micrometer is a millionth of a meter. For liter, the most common are liter, the base unit, and milliliter. And then for gram, you've got gram or kilogram. Occasionally you may see microgram. So these prefixes are nothing new, but we're going to review them real quick. Kilo means 1,000, so a kilometer has 1,000 meters. 1 kilometer is 1,000 meters. A hectometer is 100 meters because hecto means 100. Deca means 10, so a decameter is 10 meters. Base unit would be, in this case, meter, but it could be liter or gram. Any of the base metric units. Deci means tenth, so it can be written as this. So a decimeter is 1/10 of a meter. A centimeter, it means 100th. That's 1 over 100. And then a millimeter, that's 1,000th. And that means 1 over 1,000. So 1,000th of a meter is a millimeter. A review of notation. If you know that 10 squared equals 100, when you have a negative exponent, like 10 to the negative 2, that's the inverse, so it'd be 1 over 100, which is equivalent to 0.01. So negative exponents mean a number less than 1, positive exponents mean a number greater than 1. Here are some conversions you have to memorize, these ones that we just went over. Another important one is the fact that 1 milliliter of volume is equivalent to 1 cubic centimeter. And cubic centimeter, which is CUBIC, CENTIMETER, I don't know if I said that correctly, can be abbreviated as CC. So in shows like Grey's Anatomy or other medical shows, sometimes they'll say they need 10 cc's of a liquid. That means they need 10 cubic centimeters, which is equivalent of saying they need 10 milliliters. It's a volume unit. 1 liter, of course, is 1,000 milliliters. 1 kilogram is 1,000 grams. Some more metric conversions using unit analysis or dimensional analysis. If we were to convert 320 millimeters to meters using our method that we learned just now, using I call this the what you know. What I know is 320 millimeters, so I'm going to put that over 1. 320 millimeters over 1. And then I'm going to automatically, by habit, draw the multiplication symbol and a bar. And I'm going to pause right here and ask myself, what do I do next? The next thing that I would do is I need to recognize I'm going from millimeters to meters. What is the conversion factor for this? How are these going to be equivalent? you should know that 1 meter contains 1,000 itty-bitty millimeters inside. And this should work because millimeters will cancel. Meters will not cancel because that's what I'm looking for. And when I do the math, I'll get 0.32 meters as my answer. Let's try it again with kilograms to grams. If I'm going to convert 3.23 kilograms to grams, knowing that this is my what I know, W-I-K, or what you know, I'm going to put it here, 3.23 kg over 1. That's my what I know. And I'm going to go from kg to just g, which is grams. Don't be tempted to work too quickly and say, okay, 1 gram is 1,000 kilograms. Remember that these conversion factors must be equivalent. 1 gram is not 1,000 kilograms. In fact, 1 kilogram is 1,000 grams. Kilograms are going to cancel, giving you a bigger number, 3,230 grams. And according to our sig fig rules for both of these examples, we should be okay, because this is 2 sig figs, and so is our answer. This is 3 sig figs, and so is our answer, because remember, trailing zeros never count. If a student ran 5.8 kilometers, how many centimeters did they run? So this is another unit conversion. I'm going to start with what I know. 5.8 kilometers over 1. I need to get out of kilometers. I want to find centimeters. It's easiest to go from kilometers to meters. Going to the base unit is easier than skipping over the base unit, and that is important. So 1 kilometer contains 1,000 meters. They are equivalent. I can, with confidence, cancel out the kilometers and understand that right now I'm in meters, but I got to get out of meters. So draw another set, put an M down here. I need to go from meters to, now I'm at my base unit. I can get out of my base unit and go to the other side, to the smaller side, which is centimeters. And 1 meter is 100 centimeters. With confidence, I can cancel out my meters, and I can circle my centimeters unit because I'm done with my converting. I just got to do my math. When you do the math, you'll see that you'll get a big number, 580,000 centimeters. How would I turn this number, which is a long-ish number, into scientific notation? Find your decimal point and move it over until you get a number between 1 and 10. In this case, the mantissa would be 5.8 times 10 to the 5th centimeters. And I can circle that. Remember, the mantissa is the part that's touching the ground that's before the multiplication symbol for our scientific notation, and those are the significant digits. There are 2 sig figs here. There are 2 in our problem. Remember that these sig figs, there are no sig figs in exact conversions. They're infinite, so you ignore that in your process. Here's another one. Converting this many milligrams, 8.2 times 10 to the 8th milligrams to kilograms. This is what I know. This is what I don't know. But what you know over 1, and then put your multiplication symbol in your fraction bar. You do need to have your units while you're working it so you don't get lost. We're starting off with milligrams, and we need to cancel out those milligrams. So see top, bottom. Going from milligrams to grams, we're going to go to our base unit, is the easiest thing to do. You should agree that 1 gram contains 1,000 milligrams. And to get out of the grams to go toward kilograms, I need to put grams on the bottom, so that it will cancel from the grams on the top over there, to go to kilograms. 1 kilogram contains 1,000 grams. Let's see if our units cancel. Milligrams cancel top and bottom. Grams cancel top and bottom. I'm looking for kilograms, which better be my top right unit. So I can put my equal sign, do my math, and at the end I will get 820 kilograms. I could also express this as 8.2 times 10 to the second kilograms in scientific notation, but both of those are correct. 2 sig figs here, 2 sig figs, and both of my ways that I can express that. So a little bit more about units. 1 liter is a cubic decimeter. A decimeter is 10 centimeters. So about 10 centimeters on all, that was bad, let me go back. 10 centimeters on all sides. Just like a little box, 10 centimeters on all sides. That it has a volume of 1 liter. And 1 milliliter, which is 1 little itty bitty cubic centimeter, 1 cubic centimeter contains a volume of 1 milliliter. So these equivalencies are important to remember. So 1 milliliter equals 1,000 milliliters, which equals 1,000 cubic centimeters, which of course equals 1 cubic decimeter. Think about the fact that if a decimeter contains 10 centimeters, 10 cubed is 1,000. So mass. The mass of 1 kilogram, which we know contains 1,000 grams, is the mass of 1 liter of water. And 1 gram is the mass of 1 milliliter of water. Because the density of water, so DH2O, equals 1 gram per milliliter, or gram per cubic centimeter. In the same way that a dozen equals 12 things, let's just say 12. In the same way that a dozen is 12 things or 12 particles, 1 mole is 6.02 times 10 to the 23 things. Much more about that in class or in another video, but that is what we call 1 mole. Mole is kind of like dozen or a ream or a gross, any other collective plural noun that means a multiple set of things. I think this video will end here with that, and then the next one will pick up with a little bit about the mole, which continues into the rest of this unit, the next unit, and the entire course. It's one of the most important concepts in chemistry.